In this video, we're going to go over the final exam review, problem number 7. Okay, it says solve exponential logarithmic equations graphically and algebraically. In this problem, you're solving them algebraically and then confirming them graphically. So we're going to use a graphing calculator to verify. So first of all, to do this, usually what we need to do is isolate the exponential. If it's an exponential function, we need to isolate the exponential, the base in the exponent. So in this case, it's already, in part A, it's already been isolated. We have a base exponent equals a number, and that's what we want to solve. What we would do is we would take the log of both sides of this equation so that we can use the property of logs to help us simplify it. So if we take the log of 5 to the 2x plus 3 exponent equals the log of 812, we can then use the property of log that says we can move this exponent down in front. So it would come down in front as a 2x plus 3. We would put parentheses around it, so it's times the log of 5 equals log of 812. Next step would be to divide by this log of 5 so that we would end up with 2x plus 3. So we would divide both sides by log of 5, log base 10 of the number 5. And in that case, we're going to get a 2x plus 3 equals log 812 divided by log 5. Okay, and then what I would do is add or subtract 3 from both sides so that I get 2x plus 3. Oh, I'm sorry, we subtract 3. So I'm going to get 2x equals log 812 divided by log 5 minus 3. We subtract 3 from both sides. And then what we do is we divide by 2 to get the value of x. So this is going to be in parentheses log 812 divided by log 5 minus 3 divided by 2. So let's use our calculator and verify our answer. So let's find our answer first. So it's going to be parentheses log 812 minus log 5 minus 3 parentheses divided by 2. So the answer is about negative 0.3947. So approximately negative 0.3947. What we got on the calculator. Or let's verify this by using the graphing function of this. So we would put in the left-hand side of the equation, 5 to the power of 2x minus 3, or plus 3, sorry, 2x plus 3. And then on the other one, we would put 812. That's the right-hand side of the equation. Now this y equals 812 is a horizontal line at 812, so we got to make sure the window at least goes up to 812. Right now the window goes up to 10, so we need to raise this number into at least 812. I'm going to go by 9 to 900, and I'm going to go by 50 for each mark, so we don't have too many marks. So I'm going to push a graph here now. I think the answer that should be around negative 0.39, so this window x's are fine. It's between negative 10 and positive 10, that number is. So we should see the intersection when we graph. So here's one of them, and there's the 812. So it's going to intersect right here, and we need to find that point. So we just do second calculate or trace, find the intersect, push enter. Choose the curve. Well, we want each curve to be entered here. First curve, yes, we'll choose that. Second curve, yes, we'll choose that. Guess, well, we want to put it close to this value. So So it's saying the intersection is 0.5813, which is not the answer we got here. So we need to do some checking to see what we did incorrectly in the problem. So did I type it in incorrectly, or did I? So it's supposed to be this value. And let's just double check. Second quit. Did I type it in incorrectly? Log of 812 divide, oh, it's minus here. So let's verify that I typed it in. So I hit second enter. It's supposed to be divide up here, 812 divided by. So I typed it in incorrectly, 812 divided by log 5 minus 3. Push enter, there's the answer. So this is a good thing that we verified this, because this is not the answer by the calculator. Calculator is 0.5813. So I typed it in wrong. It's 0.5813. And if we look at the graphing part of it, that's what it said when we did second calculate. And we did intersect and enter, enter, enter. It gave us 0.5813, which was what the answer was. So I typed it in correctly the first time, but we verified it and then found the correct answer. And found our error actually in the problem of typing it in. All right, so that's how we do that. Now each problem is done the same way. All right, so we're going to do problem 2 and 3 similarly, or B and C. Okay, so problem B here is done similarly, but we have to solve it for e to this value first. So first step on this one would be to move the 20 to the other side and write 80 over here. Subtract 20 from both sides of that. Then I would divide by 10 so that I have a base and an exponent equals a number. So this is 8. So now over here I did log on both sides. Well, this is a special exponential function, so I'm not going to use log on this one. I'm going to use ln, because that's a logarithm too, but it's for base e, it's the inverse. So if I use ln on this, we can simplify it very quickly. So I took the natural log of both sides. This part, as I said in the previous problem, is just it basically undoes one another. So we get 0.05 x equals ln of 8. So we just have x equals ln of 8 divided by 0.05. That's approximately, let's figure out what that is, ln of 8 divided by 0.05. We get 41.59, 41.59 approximately. Let's verify on the calculator. Okay, so we go back to here and we're going to find the intersection again. We're going to type in the function that is given on both sides of the problem. This is going to be, the second function is 100. First function is 10 e to the 0.05x plus 20. Oops, that's minus, plus 20. Okay, and we think the answer, so I'm going to set my window where I think the answer is. It's got to go up to 100 here, so we don't need to go to 900 for the maximum here. That was 812 before, so we only need to go up to 100, so I'm going to put this at 120 and maybe 10 for the scale. But I know my answer is supposed to be 45. 41.59 is what I think my answer is, and my x answer is not big enough. It's not going to show the crossing. It's only 10 there, so I need to go at least to 50 so that I get the crossing there. So we're going to also put 10 here as my scale. So push graph. Okay, there's my first left-hand curve, and then I should get 100 just going straight across. I do. So there's my answer, and hopefully that's right around 41, because that's what it's supposed to be. and I go to intersect, hit enter, 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 and then move my cursor over so it's close to the intersection when it asks for guess. And I push enter one more time, and it says 41.59, which is what we had. So it verifies my answer. Okay, so that's how we do those. All right, now this last problem here is a logarithmic problem. So we have to first write it as one logarithm before we can solve it. So we have log x plus, so this is c, we have log x plus log of x plus 2 equals log of x plus 6. Right, equals log of x plus 6. So this one, we want it to, so that we can equate both sides, and then we can, it's like the exponential one where we had the same base on each side, and we can just look at the exponents. Here we want the logs to be the same on each side, so we can look at what's in the logarithms. So in this one, we have to put this together so we can get one logarithm. Log of x times x plus 2. Because it's a plus, it changes to a multiplication problem. Now, we can then, well, we're struggling here with the pen. Let's try again. Log of x plus 6. All right, since we have the log the same on both sides, we can basically reduce those halves out. If the log of something equals the log of something else, then this piece here has to equal this piece here, because they're both the same logarithm function on both sides. So we can say x times x plus 2 has to equal x plus 6, and we'd solve that algebraically. So we multiply this out and get x squared plus 2x equals x plus 6. We have a quadratic function here, so we're going to have to factor or use the quadratic formula, but we need to have 0 on one side. So we're going to place 0 here. I'm going to subtract x from both sides, and I'm going to subtract 6 from both sides. So when I do that, I get x squared plus x minus 6. And that does factor relatively easy. Two factors of 6 that subtract and are given 1. 1 is the value here. It's going to be x and x for x squared. We're going to have a positive 3 and a negative 2 for that answer, because these two multiply together to give you this. These two add up to 1, which is the value in front of the x. So x plus 3 equals 0. X is equal to negative 3. X minus 2 equals 0. X equals 2. So these are my two answers for the problem. Now we have to verify those two answers by looking at the original problem. If we look at the original problem, the first part of the problem says log x. Well, there is no such thing as a logarithm of a negative number, because that's the base is 10. We're going 10 to some exponent equals this value. Well, that value can't be negative 3. We can't go 10 to some value equals negative 3. 10 to some value is going to be a positive number. So this value is not going to work. All right, so I'm going to go with this one, and we're going to verify with our calculator by graphing it and seeing the intersection of the two. So let's take a look at our calculator. Go back here, clear these two out. Start with a log of x plus log of x plus 2. And then on the other one, we're going to write log of x plus 6. Now we know the answer. I'm thinking the answer is 2, so let's reset the window. We don't need to go to 50, so let's just go back to 10 here, and 1. I'm not sure how high this is going, but I don't think it's going to be this, so I'm going to go back to the original settings, which is 10 to negative, or negative 10 to 10. We might have to change the graph after that, but we're going to push graph and see if we can see the crossings. Here's one. There's the other. I can see the crossing, but let's zoom in a little bit on that area. So let's try window -5 to 5 and -5 to 5. We're going to make it half the size. See if we can see a little bit better. So there's our graph of the first one. There's a graph of the second. It does look kind of like it goes through 2. We'll just verify, calculate, intersect, enter. Under first curve, we should find a point on the curve first. So I have to go to the right a little bit, because right there's no point on the curve. 0 is not a point on that logarithm curve. There's no, so I have to go to the right till I find a point, hit enter. Then this is a point on the second curve, hit enter. I'm going to move over till I think I'm close to 2. Okay, 1.59, 1.9, there's 2, close to 2. And it does say the intersection is at x equals 2. So I verified my solution to that problem.